So maybe I could start, but perhaps, Victoria, so in some sense you're saying that all the efforts that some are making to record short videos to explain in a 10-minute clip something that is otherwise written in a book, that perhaps this is counterproductive. Is that your thesis?
No, absolutely not. No, my thesis is not clear. But you refer in particular to the last point, the third chapter, the last point regarding the technologies.
Yeah.
This is a problem. This is not just my personal view. This is the other side of the problem. I have not the solution. I do not have the solution of this problem. But I think that when we have a problem, the way to the solution is awareness of the problem. This is a big problem. You see, you have a very little experience with the conference. When we are here and Slack, pom, 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 you require your attention. But this is just one point, it's not all.
I don't, can you hear me?
Yes.
I don't really understand why interest in performance modeling is down. I feel like I have nonstop opportunities to help companies. In fact, there's so many companies asking me for my help that I actually am turning them away all the time because there's a limit to how many hours I'm allowed to be away from CMU. So, and I feel like all the companies basically have the same questions over and over. You know, they want to reduce delays. Now, I do agree that the structures that we teach, like MMK, are out of date. I feel like we have to be a lot more flexible. Like these companies, for instance, all the jobs are parallel jobs. Every single job today is a parallel job. It runs on multiple processors at the same time, and then it releases them all at the same time. So we need different queuing models. But in terms of performance being important, at least to companies, I think it is super important to companies. And several of the graduate students who are in my class said that they came back to graduate school because performance was so important that they felt they needed to come to graduate school to study it better because they didn't understand it. So in my mind, if we're losing people in these communities, like in our conferences and stuff, it's because we haven't reached out to the companies enough to get the companies to show up at the conferences and say, hey, folks, we need solutions from you.
I'm seeing a somewhat different kettle of fish in the industrial arena, and that is that there's a tremendous value placed on performance testing, but not much value placed on analysis, and not much value placed on basics. Although they really need to understand the basics. I've been doing this in industry with a bit of teaching thrown in for longer than I've cared to admit. The basic problems have not changed, which is why I resonate with Martha Larson's idea that Vittoria just described, that you want to teach what's durable or persistent. But I think also we need to find a way to link the mathematics that we're talking about to the system characteristics. And I'm fascinated more that you're discussing this parallel stuff, because the kinds of transaction-oriented things that I've seen, they don't really talk about the parallel stuff. So you must be maybe you're working in different problem domains, or you're seeing a side that I haven't seen. That's entirely possible. But one way of tying that back brings me to a point that I wanted to mention when Moore mentioned the difference between open and closed queuing networks. We may not see closed queuing networks in a system that's actually gone into production, but we will see them in testing, because load test generation tends to be with synchronous transactions, and that means basically a closed queuing network model. And the only way to bump up the load is to increase the number of virtual users, which is what Load Runner calls them. And that can lead to some very weird results, such as the response time approaching an asymptote instead of going sky high when you've got saturation going on. And I think there's an opportunity to tie the testing results to the mathematics. And also there's one of the things that we want to explain to people in industry, and this is actually harder to do now that cloud measurement has become so obtuse, is that as you're cranking up the load, you want to see linearity in the utilization with respect to the throughput, for example. And you want to see knees and response time curves and stuff like that. And also, I have a question about whether the level of detail of measurement that one can see allows one to see the variability that Moore was describing. Because a lot of the load testing tools that I've run into only spew out averages if you're lucky, or they may spew out percentiles, but they don't see the variability. So even though I worked in variability longer ago than I care to admit, my first thought when she described the low utilization was software bottlenecks.
So,
which is very often a configuration issue.
All the companies I'm dealing with, they're not using any standard packages. They're writing their own simulators. I totally agree with you that people are using simulation to drive their decision making. They're
Right.
definitely not using analysis. I completely agree with that. The first thing that I see
Simulated
doing,
loads.
yeah, the first thing that they do in a company is they run a simulation. They don't always do closed simulations. They also do open simulations, open loop simulations. But they definitely run their own simulation. They build their own simulations to study things. Where I come in is I try to guide them as to what to simulate because I have knowledge ahead of time as to what kind of algorithm is going to work well.
I know that story.
Yeah. It's really a problem that we have not gotten companies involved in our work, that in our conferences. It's really a problem that we've not gotten more funding from companies in the conference. And both
ICPE goes that way, by the way. We have about 70% academic, 30% industry. It varies from year to year. But because we're jointly sponsored with SPEC, which is industrial, we actually have a lot of company involvement.
And that's a good thing. It's good to have a lot of companies at the conferences, just like at the big systems conferences. It's good when companies are half the audience. I don't know, that's my opinion.
Is it a good idea to bring the companies into Sigmetrics and IFID?
May I speak?
Sure.
Gianfranco. I apologize. I joined the workshop late because of some vaccination problem.
We can't hear you.
I'm sorry.
So I didn't hear the first talk by Moore. I have some experience in teaching. You don't hear me at
Gianfranco is
all, or
you are cutting off. I mean, like there is, yeah, we can't understand. I mean, like it's just not even 50% of what you're saying comes across.
Again. Maybe the connect. Okay, you try again.
I try to fix it and then I come back.
Good. This is good. We can hear you now.
You can hear me now?
Yes.
You can hear me now?
Yes.
Yes.
Oh, okay, good. All right, so I apologize because I joined the workshop late. I had some COVID vaccination problems, so I was busy before. I didn't hear the talk by Moore, so I don't know if my observation makes sense or not. I still have a basic problem, which is probably a little bit different. I notice in my experience of teaching a course originally on performance evaluation with queuing networks and so on and so forth, and then later mostly on discrete event simulation. And I still think that even with simulation, there is a lot of theory and things which is really behind that people should know, even if they are using simulation instead of doing analysis. Nevertheless, doing the simulation in the right manner is not an easy task, and it's something that users should know. So my point, or my objective when I'm teaching this course, is trying to make the student as educated users of packages that they will be able to find. But during my course, I ask them to really write the simulator from scratch using C or using Java, but not using packages. Probably that is the reason why I am really having, I'm not having success. I'm not having success in Italy. I'm not having success in the United States, meaning that the number of students which are really joining these courses is really decreasing every year. And that is really one point. I don't know. I really think, I really believe that university should really be stressing basics and making sure that student will be, or graduated people will be able to handle more difficult situation, and they will be able, if they have the good background, they can handle those things. If they don't have the background, they will be just using things without knowing what they are doing. And that is really very, very often the case in simulation. If you don't know what is behind, if you don't know that the number generators are important, if you don't know that the statistical analysis is important, if you don't know that validation is important, that you have to do it in the right manner, then at the end, you will be just running the simulation, and you take a point estimate coming up from one run, and that is your the basis for your decision. And we know that that is probably not really very reliable as a method. But the real problem that I have been facing, and I have this experience now of 5 years of teaching more or less the same course in Italy and at Iowa State, it's been really very, very frustrating from that point of view. And in fact, because of what I was saying before, Vittoria, that the basic courses are not productive, and so they are really cut very often. I don't know if the other people that really made the first presentation, if they have the same feeling, or if they have been able, by teaching in different manner, being able to attract a lot of students. For sure, I know that the way in which I am teaching, which is probably old-fashioned, is not attractive. So I really need to work probably with some younger person, which is more capable with deal with the technology in order to make things more attractive. Still, without crossing away all the basics, because I really think that basics are important, and you cannot just learn what is behind just a simple MM1Q, or better if it is MG or something like that, by just looking at the way in which the profiles are really coming out. But evidently, the students and the society in general are not really they're not valuing these things. And so I really, in my experience in the United States, has been that the first 2 years I had several students from industrial engineering, and they were very good because they were very interested. They were not very good in programming, perhaps. So developing the simulator from scratch was a difficult task for them. But then they turned out to be very good students. I really had a very, very nice result with them. With computer science people, I must say, I am a computer scientist. I've been really teaching computer science for many years, and I must say that evidently I failed.
So if I may add something to this, Gianfranco, because we are also teaching simulation from the same book, right? Which I find that this is really the best book to teach practical simulation. But the problem that we have a lot of times with the packages is like, okay, this exactly this thing that you said, if it's garbage in, it's going to be garbage out, right? So we really need to understand what's inside the box. So we have like, but there is the tendency so much to be like this black box approach. I just provide the input, and then this thing is going to provide me the output somehow, but I don't know what's in the box. And then what I find actually most challenging is the level of like two things that I find, like two points of view. One, from the point of view of the students, who, as time goes by, I find that the quality and their mathematical ability just drops and drops. So this is like a problem going back into the fundamentals. They think they want, like, there is like this tendency, maybe the way we teach some of our courses, other courses, this immediate gratification that you can get something and get like a correct outcome right away. Oh, the success of Python, so much easier. But there is like this point that we need to understand the fundamentals. So and this takes time, and the mathematics of it, and this is harder. So that's from the point of view of the students. But I'd like also to make another point from the point of view of people who work in industry, collaborators, and especially people who work in the broader systems area. So I have been in shock sometimes because I collaborate with people in the industry all the time, and I've been like in shock several times, but their lack of knowledge. So when it comes like to some basic stochastic characteristics and stochastic things, like for example, okay, let's assume, I'll give you like a very simple example here. Let's assume in the absence of any knowledge about an arrival distribution, the arrival process, let's assume that we have Poisson arrivals, right? If we don't know anything about the arrival process, and they're like, oh no, this is not reasonable at all. And that's because they don't understand the fundamentals. So I had to explain to them the relationship between, like, what does Poisson mean? What does exponential mean? What does random arrivals within like a uniform time mean? And then sorted arrivals versus unsorted arrivals. I mean, this is textbook material. But then you have people who are prominent researchers in industry who dominate the system conferences, who just that do not know this basic thing, which is like, how then we have like a big gap there, and that's because there is like this always wrong assumption that, oh, all these theoreticians, they come up with these like very unreasonable assumptions. So that's something, I don't know how to fight this thing, but my experience was like, oh my God, you got to go read an undergraduate textbook to open up your eyes, really. But
you're absolutely right, Evgenia. People in the systems, people really don't know the basics. I've yet to meet somebody who understands the Poisson process. We teach it to undergrads. That's how we solve the problem. So yeah. We teach, I co-teach an undergraduate course, about 125 students, and they're forced to learn all of stochastics. Every year, and there are way more who want to take it, but I limit it to 125 students. And I actually give them a test at the beginning of class, and if they're not good enough in math, they don't get into class. So, and then they do a full undergraduate course on learning this stuff. And it's the only way is to teach them in large bulk, bring in a whole bunch and make them learn this stuff. Because otherwise, you're right. They go on to be prominent people in other areas, and they do not know any stochastics.
They also don't know experimental design.
That's true.
It's like part of the garbage in, garbage out. It's part of this problem.
When I was teaching performance, my best students actually came from natural sciences or economics, not computer science, because they were used to handling quantitative data and thinking experimentally.
Kathy?
So in my class, most of the students industrial engineers. We have, a few computer scientists, because computer science, they have other options. But a few things I think to address. First, I agree with you all that, all those comments. So I often tell the students since the beginning, I think nowadays there's so many, software packages available. So I think, people are treating performance modeling increasingly kind of, people are abusing the software. So they're using it in the wrong way. So basically the first thing I tell them is you have to understand the basics so that in order to use the software, correctly. So that's the very first thing. And we also emphasize garbage in, garbage out. The other thing I do with the industry is that every year in my course, I always invite people from industry. Like, for example, we invite people from Honda, Abbott. So all this, asking them to share, and their stories. I think, fortunately, a lot of time, these people, they are our own graduates. Like after they learn the simulation, they can influence, how simulation should be done in practice. I couldn't agree with more, that it's only through we training our students, then performance modeling can be done in the right way.
Idea of bringing the students that you've trained back a few years later after they've worked in industry, Kathy. That sounds like a fantastic way to get them to share with the current students what's going on. That's very nice.
Thank you. The other thing I do is that I find students, when they build the first simulation model, they really don't understand, what should be input, what should be output. What, for example, people often collect data about weighting and then make it a weighting box as actually part of the simulation model. So actually, I spend a whole lecture to tell them, when you build a model, what you can change, what you cannot change, what should be performance metric, what should be like a response to input. So that, I think, again, in practice, people often build a model in the wrong way.
Other views?
Can you hear me now?
Yes.
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 I want just to make one point. I think that we should not really blame industry or blame other about the problem. I mean that we should really also look to ourselves and to make the courses more attractive or more adequate. I agree, of course, with all what has been said about the fact that the general the industry, and not only industry, but really just common sense, is really not very, very interested in science in general, and also in our topics. But I think that at this point in time, we should really think about whether there are ways of reorganizing our way of teaching these topics in the right manner. I want to more say one thing which is very interesting to me. She said that she's teaching basic Poisson and basic things at undergraduate with a very large class. So I don't know if I'm right, so you should tell me that or not. I am afraid that that class is a compulsory class. They have to take it, or is it something they can choose?
Yes. So at CMU, you have, I think, 5 different choices for your required probability. My course is known as the most difficult by far of the required probability classes because I teach discrete and continuous, and I teach Laplace transforms and Z transforms and randomized algorithms and Markov chains, both continuous time and discrete time Markov chains, all in one semester. So in my class, you're really going to work.
Mm-hmm. And that is at the level that is really tagged as a probability course.
Probability. It's called probability and computing, and I'm just finishing a textbook for it right now. Okay. So I mean, the textbook's done. I need to get the publisher, whatever. But it's called probability and computing is the name of the course, and it's one of the options. It's one of 5 options that they can take. They can also take instead. They can go to the statistics department. They can go to the math department. There are a lot of other choices. They can take an easier computer science class. At CMU, they like to take hard classes because I don't know what. That's the way students are. I do make the course attractive. So one of the things that I do is I get funding from Citadel, and $4,000 every year, every semester. And I buy all sorts of prizes and candy and all sorts of things. Here, I can show you in my office. Here's a bag of things, all sorts of things that get thrown at students. And the class is entirely interactive. They speak constantly, and I'm constantly throwing things at them. There are all sorts of competitions and games and things being thrown at people, but they do very long homework every single week.
Yeah.
And they actually learn, and every single one of them knows what a Poisson process is with no problem.
So we have been discussing the situation with students and engineers in the largely American context. Could you hear from Giuseppe and Jean-Yves about how things are in Europe?
Well, I wanted just to ask to more if you ask a very simple question to your student at the end of the course, which is the main difference between service time and service rate, and maximum service rate and effective service rate, and why do you have if the arrival rate is less than the service rate? I would like to see how many of them are able to answer to this simple question, because really I think this is really confusing at the beginning of the course for students, the concepts, if they don't have a very good basis on probability and statistics that now are lacking more and more on time.
I mean, I agree. They need to learn probability, and believe me, when they start the course, they're sophomores and they don't know how to do an expected value. They definitely do not know how to compute the expected value. So they have no way of understanding that. I think who was it who gave the talk with the I think it was Kathy who gave the talk with the newspaper, like how many newspapers. When they start the course, they don't know how to figure out the expected money that you make. They don't know how to condition on the number of people who order the newspapers or whatever. They don't know that. They have to learn it. But my feeling is, if we don't train the undergraduates, then we will never have PhD students who are ready to learn, right? We have to teach it to them as undergraduates. So, yeah, I mean, what are we going to do?
Looking the problems that they submit to the forum and the discussion forum of GMT, so users can ask questions, are really so basic, so very elementary questions that you may say, why there is some ignorance in the world about students about this fact. This is a problem. So I agree with you. The problem is to teach to undergraduate the basic concepts much more deeper than now in this idea. Thank you.
But I really think that can you hear me now? Yeah. But I really think that one of the problems is really that of being able to address many students. My point right now is that I just completed yesterday my course, the 48 hours of course on basic discrete event simulation, and at the end I had 4 students. That is just too small as a number. Then at the end they say that they like the course. Of course they say to me, so probably is a biased opinion, but in general they say that they learn a lot by just doing everything from scratch, doing the analysis, doing the validation, and then comparing the result that they are getting from simulators with analytical result that we are producing using the operational analysis approach. So all these things, but the real problem, my problem, is that I only have 4 or 5 students. on a computer science curriculum that has at the beginning here in Italy more than 300 students as a freshman. So that is the point. Yeah, at least that is one of the problems. But I'm really saying again, I don't want really to blame somebody else. It's evidently the way in which I have been teaching this course, in which in general the curriculum is set up, that is really not favoring basics. And when I'm saying that it's not favoring basics, my experience is that not only they are not, most of the students have problems in probability, they also have very many problems in programming, in real programming from scratch. Last year, when we had when there was the pandemic and we had to switch quickly from in person to online, then I had, for some reason, last year in Iowa, I had about 20 students, which is really a huge number. I even had a TA because of. But since I'm asking them also to build their own set of functions which are really that you use to handle the future event list and things like that, which are just very simple, playing with lists, they turned out that they were not able to do it. And those were computer science on the third year or fourth, or the beginning of the, and software engineering people, which I think they were very good in doing other type of application. I'm not saying that they were stupid at all, but when I asked them to do those things, to really build the scheduling function, the one which is really handling the future event list and things like that, I had to provide them with my own solution because they were not able to get out of the problem. And I am afraid that this is true for a lot of other basic things because very often the curricula are really focused on application, on new things, and this is now I see that as a problem because from one side we are attracted from other things. The field is really becoming larger and larger and larger. But on the other hand, probably what Tripathi was saying, and then Vittoria was reporting, university should really not be a vocational, a technical school, which is really producing programmers or people which are just immediately useful for industry, but then they need continuing education because otherwise they will not be able to deal with the evolution of technology and of the field. I don't know. I don't have